Let's have a look at the answers to number 1. Was number 1 relatively easy? Yes, it should have been, hopefully, for you. Okay, the graph shows the mass of 3 substances for volumes between 0 and 60. What is the mass of 30 centimeters of each substance? 30 cubic centimeters, right? So 30 would be like right there. So you should have said like, that's 100, so each one's 25, right? So like about 60. Now, what if you wrote 58? Is that okay? Yeah. Yes, of course. It's an estimate. If you put 27, that's too far away. I don't know where the cutoff line is. It's subjective. The next one up is just under 100. Let's say 90 or 95. And this one here is, looks like it's right at 150, is it? Good. You can read graphs. If you had 100 grams of each substance, what would their volumes be? You're going to go the other way now, right? 100 grams. So it would be like 20 cubic centimeters. And like, 35. Yeah, about that, 35. Yeah, now I guess like exactly. 35 and 50. Is that what you had? Close? Awesome. We're having a good day. Okay, what are the units of the slope? Was this question hard? A little harder, but I showed you yesterday the units of the slope. Remember, slope is the y over the x, so it's the slope or the units of the y, which are grams, and the units of the x, which are cubic centimeters. So the units of the slope are grams per cubic centimeter. Mine is different? Oh, you do? Oh, you do? Okay. I gotta fix my... Thanks, Kurt. I gotta update mine, I guess, eh? Okay, I'm gonna do that. Did I do the right question, though? What are the units of the slope? Okay, so I'm still good. So grams per cubic centimeters, right? Okay, what is the value of the steepest slope? So you have to actually find the slope. Sammy asked a question, does it matter what 2 points? So she said no. Actually, you said it doesn't matter, right? You were confirming it. Does it matter any 2 points? Doesn't matter. It's a straight line. Okay? A lot of people like to pick the first one and the last one. And quite often those are good choices because the first one is quite often at 0 and 0. Okay? However, there are times in your future when picking this point and this one, because if this isn't 0, 0, then it doesn't work as easy, right? You still have to subtract. Okay, so don't get lulled into that sort of idea. I'm going to pick 2 different ones just for the sake of not doing that. Okay? I'm going to pick this one and that one, just for whatever reason. Okay, so this one here, the y value is 150. This one here, the y value looks to be 50. The x value here is 30, and the x value here is 10. So 150 minus 50 is 100. 30 minus 10 is 20. 100 divided by 20 is 5. Did you get something close to 5? If you got anywhere between probably 3.5 and 7.5, if you showed the work, I'm going to give it to you. The work is way more important than the number. Catherine, it's 5 what? Grams per cubic centimeter. Well done. 5 grams per cubic centimeter. E is the hardest question of the bunch. Describe the meaning of the slopes of the lines and graphs. What does the slope actually represent? What scientific quantity? And you might not know this answer. So, does anyone know, what do you measure in grams per cubic centimeter? Does anyone know? I don't, at one time it was taught in grade 9 or 10, but I don't think it is anymore. So I don't know when you guys talk about this. Worry about it. Does anyone know? Martin, do you know grams per cubic centimeter? It's kind of weird. No? Anyone? It's okay not to know. Anyone ever heard of density before? Yeah? Hell yeah, density? Where'd you learn it? Don't know? Yes. Grams per cubic centimeter is the unit for Density. You may have seen the formula D equals mass over volume. Have you ever seen that? Mass over volume. What's the quantity of the Y? Mass. What's the quantity of the X? Volume. So what is the slope? It's mass over volume, which is density. What's the density of this substance? It's 5. 5 grams per cubic centimeter. The density of the pink one would be like about 3 grams per cubic centimeter. The density of this blue one at the bottom would be maybe 1, right? The slope has a meaning, a property of the system that it describes. Okay? That's what I'm trying to get at. Is that good? Sort of, give me kind of a nod, yeah? Kind of? Okay, good. All right. You need a little bit more time for number 2? Yes? Okay, if you're done 2, you can go on to 3. I'm going to give 5 more minutes, and I'm going to give you the answer for number 2. During an experiment, the student measured the mass of 10 cubic centimeters of ethanol by pouring it in a graduated cylinder. The student then measured the mass of 20 and so on. They got that data. Plot the values given the table and draw the curve or line that best fits all points. Did you get a 100% perfectly straight line? No. Is it sort of pretty close to a straight line? Like 95%-ish? Something like that, right? Okay. Generally, you would get results sort of like that. I will just very quickly do that here. You'll notice that the graph is blank, right? So you probably went up 10, 20, 30, 40, 50. It's pretty obvious, right? Is it 5s or 10s here? 5s? Okay, so 10 and 11 would be about there. 20 and 18.9 would be like about there. 30 and 26.8, about there. 40 and 34.7, almost there. And 42.7, pretty much right in the middle. Okay, now here's the part where I saw lots of different things. I saw people doing this. I want you to draw a line of best fit. Now, I have a real hard time doing that up here because obviously I can't just put a ruler on the screen. Okay, but I can do this. Okay. Basically, you go in there with your ruler and you estimate just sort of estimate with your eyeball kind of thing, the line that goes through as many data points as possible, or as close to. Because this is like a 95% line, it's relatively easy. Come on. Okay? Something like that. Okay? It should be a straight line. It should not be connect the dots. Okay? And then you pick 2 points that are representative, that are on that line. Now, I didn't do a real good job there. I'm going to pick that spot. That one. Well, I guess I should draw my line first. Okay, I'm going to pick that one and that one. But yours could be different. And then you find the slope. Describe the resulting curve. Do you have that? No, you have find the units of the slope. What is the name given to this quantity, right? Is it a line or a curve? It's a line. It's a linear relationship. Find the units of the slope. The slope, this is grams. This is, again, cubic centimeters. So it's grams per cubic centimeters. We're talking density again. What is the value of the slope of the line of best fit? So then you find the slope. So here's the part where if you're not sure about how to do slope, you need to watch this, right? The x and y coordinates. This is at 30, 26.8. This one is at 10, 11, right? y2 minus y1. Which is my y2? 11 or 26.8? 26.8. The y2 is the one to the right, further to the right. So 26.8 minus 11. Subtract the x's. 30 minus 10. 26.8 minus 11 is going to be 15.8. All over 30 minus 10, or 20. Someone do that for me on a calculator. 15.8 divided by 20. It's about like 0.75 almost. What is it? 0.79? Okay. 0.79 what? Grams per cubic centimeter. What if you got 0.8 or 0.81 or 0.78? Is that okay? Yes. What's important is this work. The work is important. I don't care about the final answer. If it's in the right ballpark, I'm good. Show me the work. Okay? Write an equation relating the volume to the mass of the alcohol. This is volume. This is mass, right? So the mass is equal to, what's the slope? Remember, like y equals mx plus b, right? What's the b value? Oh, what's the b value? We don't know. About 3? Okay. How'd you get 3.1, Mark? You just guessing? Okay. So y is my mass. What's my m, my slope? This number here, 0.79. What's the x represent? Volume. Mass equals 0.79 times the volume plus the y-intercept, which Martin says 3.1. If you want to write it in sort of formula notation, I guess it would be m is equal to 0.79 v plus 3.1. Now you might say, we've never done anything like that, Mr. Nance, but I know you have. You just haven't sort of done it in that real life kind of application. You've just done crazy numbers, right? X's and Y's. It's the same concept. Okay? And we're going to do more of it, so don't worry. I'm not going to test you like tomorrow and then that's it, okay? So relax. 0.79 v plus 3.1. Now the last question is, why isn't the y-intercept equal to 0? How come when they weighed all this, like if you've got 0 volume, how come you've got 3.1 grams? How come something 0 weighs 3.1? Anyone know? Someone knows out there. I know you know. Jaden? You can have mass, but I do. So like it should be 0, but how come it isn't? I guess there's two possible answers. One is that the person is not a very good measurer. Made a mistake. But there's a little bit more reasonable one.
Drank some of that alcohol.
Mass of the graduated.
Exactly. How did they put, what are they measuring here? They're measuring ethanol in a graduated cylinder, and they forgot to subtract the mass of the glass container, the graduated cylinder. How much does the glass container weigh? 3.1 grams. When you do measurements, and if you've been in Mrs. Gannick's class last year, she's got those fancy electronic balances. You put the thing on there and it shows like 3.1 grams, and then you hit the tare button, and what does it do? It resets it to 0. They forgot to do that. And they forgot to account for the mass of the graduated cylinder. That's what they forgot to do. That's your answer for E. They forgot to account for the mass of the graduated cylinder. Now, does all that help you with number 3, do you think? No? 5 more minutes for number 3?
6 and we got
5 more minutes for number 3. Go.
I like drinking.
During a demonstration, the instructor places. Oh, I got to read from the other one because mine was changed. Instructor placed a 1 kilogram mass in a horizontal table that was nearly frictionless. The instructor then applied various horizontal forces to the mass, measured the rate at which the mass gained speed or was accelerated for each force applied. The results of the experiment are shown on the table. Plot the values and draw the curve or line that best fits all points. Did you get a straight line? Yes. Is it perfect? No. It's like anything. It's not going to be perfect. 5, 10, 15, 20, 25, 30. I'm going to go up by, looks like 5. I'm going to graph 5 and 4.9. It's almost right. Okay, so your line of best fit is, these are almost perfect, aren't they? Right? Your line of best fit pretty much is right like that, isn't it? Right? Again, it's your line of best fit. You're going to be slightly off, okay? Plot the values, draw the line, curve a line, describe in words the relationship between the force and acceleration. Is it a linear relationship? Did it create a straight line? This is acceleration, this is force. So you would say something like force is linearly or directly proportional, and I probably didn't explain this well enough, directly proportional to, actually it should be acceleration first. The y comes first. Acceleration is directly proportional to the force. Directly proportional is code for linear relationship. You could say it's linearly related as well. It's hard to say, linearly. The acceleration is directly proportional to the force. It's a straight line. Write the equation relating the force and the acceleration of the relatives from the graph. In your sheet it says, find the slope and estimate the y-intercept. Martin, what did you estimate the y-intercept? You seem to be the expert. 0. There's no measurement here. If the guy pushes with 0, what's the acceleration going to be? 0. The y-intercept is 0. What's the slope? I can tell just by looking at it, the slope is pretty close to 1. Did you get a value close to 1? You should have. Any 2 points will do, right? This is going to be 29.9. This one here is going to be 9.8. The x here is 30. The x here is 10. And whatever works out to, it's pretty much 1, isn't it? 0.99 is fine. 1.01 is fine. The work is what's important. Write the equation relating the force and the acceleration of results in the graph. What is your equation? You would say y equals mx plus b. What's the y quantity? Acceleration. What's the m value of slope? 1. What's the x quantity? Force. What's the value of b? Can you simplify that? Sure. Do I need 1f? No. Do I need plus 0? No. In fact, in this case, the acceleration is equal to the force. It's because of the mass. The acceleration is equal to the force. What's the formula that you guys know with F and M in it? It's F equals ma, isn't it? Right? That's the one you should know. Does the slope have meaning in this situation? What are the units? Meters per second squared. Here it's measured in newtons, so the units of the slope are going to be meters per second squared per newton. Does that have any meaning in real life? Not really. Yes. You don't know. I sort of know. The answer is no. It doesn't have meaning. The slope doesn't always mean something. There is no meaning in this case. Okay? I'm not going to throw curveballs at you like that on a test. Okay? But I want you to realize that the slope doesn't always have meaning. Okay. You're going to have to bear with me. Should I bother doing this?
What am I going to do so much here tomorrow? Will I just go on to the school here and just look at that?
Okay, here's what I want you to do. If you have a laptop in front of you and you have Excel started, I want you to just type this data into this last one. It's number 3. Can you do that? Type in the data from number 3, and I'm going to come around. I'm going to show you how to make a graph real quick, and then I'm going to probably review it all again tomorrow. But we've got the laptop, so doesn't matter to this side. If you haven't logged in yet, yeah, so put force on the left-hand side, and then acceleration. Type the numbers in, so you can carry a graph. Develop those, and we're done.
Will this stuff be on my for tomorrow?
Tomorrow?